Alternating current periodically reverses direction, alternating between positive and negative. In the U.S., AC electricity is distributed through the power grid to homes and businesses. Direct current, which is the type of power available from batteries, flows in only one direction. To use a DC motor, the AC from the U.S. power grid must first be converted to DC before being fed to the motor. AC motors run at the speed of the frequency of the AC supply. To adjust the speed, the AC must be converted to DC and then converted back at a different frequency. This adds costs and can shorten the lifespan of an AC motor. When you think of the best applications for an AC motor, think of continuous speed. The speed of DC motors is changed simply by modifying the supply voltage. This does not shorten the lifespan of a DC motor. When you think of the best applications for a DC motor, think of a need for speed control. AC motors are less efficient because AC motors use electromagnets to operate. Electromagnets must be supplied with electricity to be effective. DC motors are more efficient because DC motors use permanent magnets instead of electromagnets. Permanent magnets do not consume electricity. This efficiency difference between AC and DC motors can be as much as 50%.
Cost less than DC motors because there's been a greater adoption of AC motors in the US, and this widespread use means AC motor manufacturing benefits from economies of scale. DC motors cost more than AC motors because their manufacturing costs are higher. AC motors do not have parts that rub against each other and therefore have a long lifespan. DC motors are available as brushed or brushless. Brushed DC motors wear out because the carbon wire brush constantly rubs between the motor's rotating component and the center. This brush wear can even lead to sparking. Brushless DC motors do not have parts that rub against each other, so they require less maintenance. As you might guess, an AC motor is quieter than a DC brushed motor because the components of an AC motor spin freely from one another, whereas the components of the brushed DC motor rub to pass the electric current. However, a brushless DC motor can be smaller than an AC motor of comparable performance. The brushless DC motor will therefore be quieter.